So total monthly cost. So, and then when we read is a function of, what it's a function of is our input. And so what's our input here? Yeah, that's going to be the data used. In gigabytes. And then this is in dollars. So then when we write a piecewise function, we write f of x equals, and then we do these curly guys. And then we're going to explain how to calculate the total monthly cost based on how much data we use. So it's $80, like a flat rate of $80, when? If you use 5 gigabytes or less, right? You still have to pay the same amount even if you don't use all of your data. So f of x is equal to 80 if x is between 0 and 5. So I included both 0 and 5 because if you don't use any data, you still have to pay for your phone, right? And if you use exactly 5, you don't have to pay any extra. So both 0 and 5 are included there. And then if you use more than 5, how would we calculate the total cost? So like say we use 50 gigabytes. How would you calculate the total cost?
80 plus 10x.
So if we did 80 plus 10 times 50 for 50 gigabytes, does that look right? Why would we subtract 5?
Because you already paid for 5.
Yeah, so we only want to multiply 10 by the number of gigabytes beyond that first 5, right? Because we don't want to pay twice for the first 5. So we're multiplying 10, in this case, by 45 if we use a total of 50 gigabytes. Does that make sense? So we would do our original $80 plus 10 times, whoops, not 50, x minus 5. For this type of function, one thing you can remember is like these two numbers kind of correspond to each other. Like we pay 80 for that first 5. So when we start with the $80, we have to take off the 5 that paid for from our input. So you're always subtracting the input that original cost pays for. And then this is if we use more than 5 gigabytes. Whoops. So the way that we evaluate these guys, is everybody cool with the function itself?
So you have to plug in a number over 5 for it to work? Because if you plug in 3...
So, well, great question. So if x is under 5, this tells us to use this line, right? So the way we evaluate these is we first have to think about which line to use, so which rule we're going to use, and that's what these two things tell us. So when I look at, f of 1, I think to myself, my input is between, I was doing this all day, between 0 and 5. So we're going to use f of x equals 80 as our function. So when we're plugging a number in, our function becomes just like any other function we've seen. It's f of x equals one of the rules. We just have to decide which one to use. In this case, we're using f of x equals 80 because our input falls in this range. So f of 1 equals 80. Good. And Garrison's right, like we can't just use that second line for all of them, right? Because that would give us if we had like 1 gigabyte, we'd have -4 times 10. That would be like if they were giving us money back for the data that we didn't use. So if we didn't use the entire 5 gigabytes, they're not going to give us money back for what we didn't use, right? So that's why we need 2 rules, because there's no one rule that will work for every x value. So if x is 5, which rule are we going to use?
Same thing.
Yeah, the same thing, right? So 5, whoa. Stop. 5 is less than or equal to 5. So we're going to use f of x equals 80 again. So f of 5 equals 80. So now to do f of 10, here my input is greater than 5. 10 is greater than 5. So we're going to use the second line. So f of x equals 80 plus 10 times x minus 5. So once we figure out which one we're using, we plug in our input the same way we always have when we evaluate functions. So f of 10 equals 80 plus 10 times 10 minus 5. So 10 minus 5 is 5, times 10 is 50, plus 80 is 130. Does that make sense? Like how we picked which one to use and then used it? Any questions on that? Okay, let's sketch this graph. We're not going to do any details here. We're just going to look at kind of what happens at 5. So to the left of 5, so for x values between 0 and 5, this is a constant function, right? It's just a horizontal line at 80. We'll pretend that's a horizontal line. Horizontal-ish. We're going with it. And then after that, what type of function is f of x equals 80 plus 10 times x minus 5? Yeah, it's linear, right? Because if we distribute that 10, we're still not going to get an exponent on our x, right? We're just going to get like 10x minus 50. And so remember, linear functions are functions where like nothing funny is happening to your variable, basically. So you're not like taking the square root of your variable. You don't have it in the denominator of a fraction, and there's no exponents other than 1 on the variable. So it's linear. Is the slope going to be positive or negative? It's going to be positive 10, right? We get a 10x. And so it's going to look something like this. So, and those meet because if we used, like, even though we wouldn't plug 5 into that second function, if we did, we would get 80, right? If we plugged 5 into the second formula. And so that means that this line is going to get infinitely close to that point, right? So like if we plugged 5.00000000001 in, we would be really close to a y value of 80. So they're going to meet up there because that's the point that that line would go through if we continued it. So one way you can think of it is like on the line that we use for the second rule, this is an open point, and then the other one comes along and fills it in, like so. So let's look at these graphs in a little more detail. So the first thing we're going to do to graph these is we're going to find the endpoints of each piece. So I'm going to find points of each piece. So in this case, we had an endpoint right here because we didn't go to the left of 0, right? Our function didn't apply to anything less than 0. And then there was another endpoint right here. That's where they switch, right? So that's where that horizontal line ends and where the other line starts. So it's an endpoint, not of the entire graph, but of each individual piece. And then there's no endpoint on the right because x can be anything above 5. There's nothing that stops it. So in this case, our endpoints are going to be at 2 and 6. And like for these endpoints, like literally, it's just the numbers that are over here every single time. So we're going to make a table, and it's going to have 3 columns. So you're going to have 1 column for your input. Maybe. And then you're going to have 1 column for each piece. So the first piece is y equals -1/2 x minus 1. And the second piece is y equals the square root of x minus 2. So our endpoints are at 2 and 6. Since we don't have a left endpoint, so there's no number over here that tells us to stop there. We can do anything that's to the left of 2. So we can do any number less than 2. I always go at least like 2 numbers less than that. So I'll start at like, in this case, I'm going to start at -1. No, I'll start at -1. 0, 1, 2. And then I have to go up to 6. So 3, 4, 5, 6. And then my endpoints, I have 1 at 2. And then I have 1 at 6. And I always separate those out because that's sort of like where the interesting stuff happens. So now to find the points on the graph that correspond to those x values, we're going to plug them into the function. I see 2 on both lines, so I'm going to plug it into both functions. So if I plug 2 into this first formula, I get -1 minus 1 is -2. And if I plug it into the second one, I get 2 minus 2 is 0, and the square root of 0 is 0. But those can't both be open. Let me make this look a little different. There we go. Those can't both be points on my graph because it's a function, right? And I can't have 2 outputs that correspond to the same input. So one of those points at least has to be an open point. So that's the next thing we do is determine if endpoints are open or closed. And the way we do that is with the inequalities. So strict inequalities give us open points, and inclusive inequalities give us closed points. So I'm in this first column, so I'm looking at the first line. The inequality between the x and the 2 is inclusive, and so that's going to be a closed point. Does that make sense? So then when I'm in the second column, that corresponds to the second line. And the inequality between the x and the 2 is, is a strict inequality. So that gives me an open point. So now for my second endpoint at 6, where do you see the 6? Yeah, just on that second line, right? Which means we're not plugging it in for the first one. So we saw 2. 2 was in both of those inequalities, and so that's why we plugged it in both lines. 6 is only in one of them. So 6 minus 2 is 4. The square root of 4 is 2. Is that an open point or a closed point? It's closed because the inequality between the x and the 6 is inclusive. One thing about these open and closed points is they only happen at endpoints. I mean, well, all points on a graph are closed points, but open points can only happen at the endpoints. You're not going to have like any closed points like in the in-between, like in here. It's only at the endpoints that you'll have an open point. So the next thing we want to do is plot the points on each piece so we can graph each piece individually, so in between the endpoints. So we're going to find at least 2 points for each piece of the graph. So this is one piece. This is the second piece. That's why we call them piecewise, right? So we're going to find first points corresponding to x values that are less than 2. So which formula should I use? The first line or the second? The first, right? So this rule corresponds to x values that are less than or equal to -2. So I'm not going to use that one at all. What type of function is that? It's linear. And it's got a negative slope, so it's going to look something like this. It's nice to know the basic shape of each piece of your graph, because then you can find less points. So -1/2 times -1 is 0.5. So this is -0.5, -1, and -1.5. Really, because you know it's linear, you could have found just like one other point, because then you'd have a straight line through those 2 points. Now, if we want to find y values for x values between 2 and 6, what should we use? The second one, because that applies to x values between 2 and 6. So we don't need anything over here for those x values. Let's see, 3 minus 2 is 1, the square root of 1 is 1. And these are messy decimals that I don't even want to graph. Do you guys know the general shape of the square root function? It's like a sideways parabola, but it's only like the top half of it. So like if I were to do like a sideways parabola like this, but it's only the top bit, so it's just like this little like hook thing. So square root is going to look like this. And because I know the general shape, I don't need every single point in between. I've got like 3 points and I know the general shape. So I feel pretty good about graphing it without all those yucky decimals. I mean, those decimals would just be approximations anyway. So now we're ready to graph. So graph using points found and basic shapes of functions. One thing about graphing piecewise functions is it gives us an opportunity to really think about like what type of function things are. So far we've looked at functions like one at a time. Like we looked at linear functions, and then we looked at quadratics, we looked at rational functions, we looked at radical functions. So we've looked at them kind of like one at a time. So like you didn't have to like determine what type of function it was because we were in like the quadratic section or the linear section. So now this is sort of your first opportunity to like distinguish between different types of functions, which is an important skill because you need to know like the characteristics of functions are all based on what type of function they are. So take the time to like ask yourself like what type of function is this and what's the basic shape of its graph, because that will not only help you get your graph right, but it's good practice for later on when you're given a function in calculus. It's not going to be in like the quadratic function section. It's just going to be some function, right? So you have to determine what type of function it is so that you can know how it behaves. So we're going to start by plotting all the points on the left side. So in the left column we have, I'm not even going to plot them all because I know it's a straight line, so I'm going to just do the nice ones. 2, -2. At 2, -2, this is a closed point. And then this is a straight line. And it has an arrow on the left because I don't have any number over here to stop me, right? It's all x values that are less than 2. And so there's no left endpoint, which means I just use an arrow. It keeps going to -infinity. And then now I'm going to plot all the points on the right, in the right column. So I have an open point at 2, 0. Is that big enough to look open? And then I have a point at 3, 1. And then I have a point at 6, 2. And I'm stopping at that point because I don't go beyond 6. There's nothing in my function about x values that are greater than 6. So 6 is my right endpoint. I actually stop there. So make sure that you're not making everything a straight line, right? Only linear functions are straight lines. Well, absolute value also, we'll do one of those in a second. But everything else is a curve, so make sure that you put a curve to it. Any questions on any part of that before we do more? You guys feel good about it? Okay. So let's do another one. This one has 3 lines, so I need 4 columns. So we have 1 column for our input, and then 1 column for each of our rules. Just be straight. There you go. So x, y equals 2, and all I'm doing is just copying what's on each line. So y, you don't have to worry about like what it all means at this point. Just write it down. So y equals absolute value of x minus 1. And then we're going to think about our endpoints. We have a left endpoint at -5, right? Because x doesn't ever get smaller than -5. We don't have anything in our function for x values less than -5, so I'm actually going to start at -5. And then the other value I see here is -2, so we're going to go up to -2. But then down here, this one is for all the values that are greater than -2. I have no right endpoint, but I still have to go beyond -2, right? Because all the values greater than -2 are accounted for. And so I always just go like 2 or 3 more. So like -1, 0, 1. So I have an endpoint at -5, and I have an endpoint at -2. Where do you see the -5? Just in the first one, which means we don't need it here or here. So if x is -5, what's my y value? 2, right? That's just a constant function. So what's the graph of that going to look like? Yeah, it's just a horizontal line, right? So then my other endpoint at -2, where do we see -2? All three, so we're going to plug it into all three. So for the first one is constant at 2. The second one is a constant at 4. And then the third one, the absolute value of -2 is +2. -1 gives me +1. And now we're going to figure out if these are open points or closed points. So this first one at -5, 2, is that going to be open or closed? Finn, what do you think?
Sorry, I'm falling asleep. What was
This
the
point here at -5, 2, is it going to be open or closed?
I think it'd be.
So we want to look at the inequality between x and
Of course, it's
-5.
closed.
So it's closed. Yep, good. Sam, what about the second one? What about this one right here? Whoops, sorry, that one right there. So on the first line,
Oh, that would be open?
yeah, that would be open because on the first line between the x and -2, we have a strict inequality. Ellen, what about this one right here? So we want to look on the middle line in between the x and the -2. Are we including that?
Yeah, so it'd be close.
Yeah, so it would be closed. So if it's equal, I mean, that's just like greater than or equal, except not the greater than, right? The equal part is what makes it closed. So this would be closed. Hazel, what about that last one? So what do we look at? Right. And what line are we looking at? The third one, right? So between the -2 and the x, we have strict, so yes, it's open. Good. So now we're going to fill in our points. Between -5 and -2, Ryan, which line should we use? I mean, just like which one of those rules should we use? The first, second, or third? The first one, right? So if x is between -5 and -2, y is 2. And then when x is equal to -2, we get that output of 4, but nothing else is going on that middle line, right? Lane, what should I use when x is greater than -2? Yeah, the bottom one. So this says, by convention, like I don't know why mathematicians do this, but they really like to write all the inequalities in the